Alright, this is the first video of 8.4 that we're going to do. Now we're skipping around a little bit because 8.4 takes the three sections, 8.1, 8.2, and 8.3, and shifts them. And so since we're a little tight on time, decided that I would do the part in 8.4 that has to do with parabolas today with the parabolas. And then tomorrow we'll do 8.2, and then we'll do 8.4 that has to do with ellipses, so that we'll kind of split 8.4 up over 3 different days. So, if you recall the last video, we had these parabolas, and the general equation for a parabola that opened up is x squared equals 4py. And that is only when we have the center at 0, 0. Right? So suppose I want to get a vertex that's shifted, like to hk. We usually use hk for vertex. Then you see that the x is going to be shifted over h, right? So the way we write that is x minus h. We replace x with x minus h. And we would replace y with y minus k. And that would give us a vertex at hk. So the idea then is when you have one, and we'll talk more about how you get it into this form, but if you can put it in this form, then you can read right off where the vertex is. Okay, here is an equation, and it's in that form that we have, right? So you should be able to read off that the vertex is coming from this number, right? That's the x part of the vertex. It's how much the x is shifted. And this number. Okay, but now, you notice this is minus. This one is minus, so the shift is positive, right? And since this is in here with a y, it's not just out on the side, right? It's in with the y. It's the same thing with the y shift. It's the opposite of whatever that was. Okay, so my vertex is at 2, negative 1. I still notice it's still the basic form of x squared equal to some positive number, right? So I still know that it opens up. It's just that it opens up from starting at 2, negative 1. All right, so that's the vertex. Now, what is P in this case? Well, remember that this 12 right here is where the 4p is. So since 12 equals 4p, then p is equal to 3. Okay, so the focus would be 3 away from the vertex. So back over here at my graph, here's my vertex, and I'm going to go up 3, and that is my focus. Okay, so you see that my vertex was over 2, right? And since we're going up and down, the focus is going to be over 2. So the point is at 2, same as the vertex, right? And the y value will be 3 more than the vertex. So the vertex was at negative 1. I add 3, I get it at 2. So my focus is at 2, 2. So this distance right here is still my P. Okay, so it's just that we start counting at the vertex. Right? Now, how about the directrix? We want to be able to find the directrix. And just like before, when we go up 3, we go down 3 to find, oh, yeah, that's a line, directrix. Okay, so from my vertex, which is at -1, when I go down 3, now I'm at -4. So my directrix is the line y equals -4. And so we were able to get everything, right? The focal diameter is still going to be found the same way. It's still the 4p. And so we can read that right off of our equation. It's 12. So that means we're going to go over from the vertex over 6. 1, 2, 3, 4, 5, 6. Actually, we're going across from the focus, right? And the other way, 6. And that tells me how wide my parabola is. This equation is in the general form, okay? So for all the conics, the general form is to put the squared terms first, and then the x and the y, and then the constant equal to 0. But we can't really graph anything here. We need to get it into that form that we just looked at, right? So we want to get it into this y minus k, remember k always goes with the y, equal to 4p x minus h. And it could be plus or minus depending on which way we're looking, right? So if we want to try to get it into this form, we're going to have to do a little bit of work. So we've got y squareds. We want all those y's to stay on this side because we're going to complete the square, right? And I'm going to put all the rest of the stuff on the other side. So I have a -4 and I have a -5. Okay, so now we look at what goes here, right? What number goes there that would make this a perfect square? Well, we take half of that term, which is 3, and square it. So I really want to add a 9. That means I have to add 9 to the other side too, in order to keep the equal sign equal. All right, well, this is a perfect square now, so I can write it as a perfect square. And that side is done, right? The left side is done. Now, on this side, I want to factor out all that I can so that x has nothing in front of it. And I should add these together first too, right? So -4x plus 4. All right, so I'm going to factor out a -4 of x. And when I factor it out of this +4, I get a -1. All right, so now I have this exactly right. So my vertex is, remember that the x term comes first, it's a 1, and the y has a -3, so my vertex is at 1, -3. P is still going to be found the same way using this 4 here, right? And if that's 4p equal to 4, then p must be 1. It's negative and it's y squared, so it's opening to the left. And my focus and my diameter I can find. And I kind of like to go to the graph at this time. So my vertex is at 1, -3. So there's my vertex. Okay, and then it's opening to the left, so my focus is over P to the left. So I'm going to go from here, and my P is 1. So see how it's just over 1, and that's where my focus is. So this time, that line that goes through that line of symmetry that goes through the parabola is horizontal. So the y value is going to be the same in the focus as in the vertex, and the x value is going to have moved over to the left 1. So that will now put us at 0, but it's still at -3. Now I want to go 1 the other direction, right? Because that is where my directrix is. And since we're looking at a parabola that lays on its side, the directrix is a vertical line. And it's the line x equals 2 because we moved over 1 from that vertex. The focal diameter is still 4. And so what that means is from the focus, half of 4 is 2. So I'm going to go over 2, up 2 that is, and down 2. And that's how I know how wide my parabola is. Okay, here's your quiz question. Here's a parabola. Notice that I put it in the standard shifted form, right? You don't have to do the completing the square this time, but we'll do some in class. I want you to find the equation of the directrix. Remember, on the two examples I used, they are written as a line. Either a vertical line, which would be x equals something, or a horizontal line, which would be y equals something. So that's your question. Just write in that equation of the line.